Dut 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 bum 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 bum. Okay, so it's 1600 hours. We might as well just get started here. So nobody's on right now asking questions, so I'll just start doing some random stuff. Thought about looking at this side here, shader toy. There's a plethora of OSL shade or GL shaders on this side, many thousands, and we can actually convert most of them. Only single buffer, you can see there's a multi-pass buffer up here, but single pass buffers we can convert into OSL. Might as well just start with something light and easy. As you can see, this is the code, the WebGL code for this particular effect. So let's try and stop that one. Basically just Control C here, and I have some scene here. We can close that one. Go down here, and let's see here. We take some kind of map here. This one. Go in here. Frame it up, cover it over, compile. We start to get some issues. So the idea here is that I'll just go through it and explain what we can do about it. So this is pi. There's a define up here. Define is like a set. We can set some word to some value, but in OSL we actually have m pi that will do it for that line. So let's just delete that. Hit F7. So we see here we have a vector2 construct. We don't have vec2 in OSL for starters, but we can import it. We can also import vector4. We could also just make this a vector, but for consistency, let's just include this H file. This makes also start to look for a file called vector2h sap. Included that from the OSL GitHub. So and right now it will be triggered if we try ping it like this, but you can see in the code down here it's actually called vec2. So what we need to do is make a little define here. That's called vec2 vector2. Oh, something like this. Oh, I need a hash up there. So you can see the error. The next error is down here. So in GL, it's always they always do void main image. Our syntax is a little bit different. It's a shader. We don't call it main image. We call it what was it called? It was called. Let me see here. We call it loading icon. I'm just copying this one. Something like this. And up in the start here, if you start a line with 2 dashes, you can write whatever you want and it becomes a comment. So this is original by, let's see here, his name is Ayaha401. And it's from Shader Toy. We're going to paste this one in here. And let's see here. Okay, so let's try and check the debug here. Struct name out. Okay, so we just take this one out. And in GL, they always use frag color and frag chord. Frag color is a vector 4 construct. We only have vector 3 like this. For the output, alpha needs to go to a single float channel. So so what we can do, we can just go like this. Let me clean this up a bit first. Something like this. We just delete these two lines here. So what we always need, we need a point. I always call it PO. P, and I think we have some time down here. Yes, this is the time. It's called one time. So let's put that in there. It's a float time equals 0. This is UI entries, and we need an output. Oh, I need a name, something like this. Okay, so we have this vec2 thing here. That's the UV. It's the frag chord, but in OSL we call it PO. The frag chord is basically the UV in our domain, and I resolution is a term they use in WebGL, where they basically sample or detect the resolution of this one. Petros was the first guy to come and say something. Hello, Petros. So I'll just continue here. Let's see here. So yeah, the frag chord is the UV information, and but as you can see here, this is a vec2 construct. A point is actually a container with 3 values, x, y, and z. So, but we only need the 2 from the PO. So what we can do here is we can make a vec2, and we can source PO 0 and PO 1. This now does it for the frag chord, and in OSL, it's actually the I resolution will always be 1. So as you can see here, something divided by 1 will always be something, so we can delete that stuff. And we have doubled parentheses, so we can do something like this. We have the next issue down here. So in WebGL, we address the channels with X, Y, Z. In OSL, it's basically done like this. This would be calling the first channel in OSL, except if it's a vector 2 and a vector 4 construct. That is a bit ugly. SAP has mentioned that, so we need to pay attention to that. But in this case, since UV is a vec2 construct, it's actually legit. And you can see here I use 0 and 1 up here, calling the PO, and that will work because the point is generic OSL deal. So that's these clamps here, 0, 1, and 2, and 3 if it's a vector 4 construct. Alright, so what is it that we want to do here? Well, we want to take the X channel and multiply it with resolution, I resolution X and I resolution Y. But in OSL, these are both 1. So we actually end up with something like this, and 1 divided by 1 is 1, and we want to multiply it with this, so nothing actually happens, so we can delete it. Let's see here. So we have the UV. We're going to pass that through the vector 2. You can see here when I move the mouse over here, it's highlighting this function up here. So it's detecting where's this expression used throughout the code. We can do the same here with col, and it highlights these. So the UV is piped through this function up here. These are external functions, and this is another external functions. This shader contains two external functions. So let's see here. UV, we're going to rotate it. We're going to rotate the UV over iTime, but iTime is a WebGL thing. Petros, yes. Also is perfectly fine with other renderers as long as they support the generic OSL implementation. You can have a little bit of conditions with these the calls to these vector 2 and vector 4 construct, but those are also part of the generic OSL implementation, so it should work fine. If this causes any problem in other renderers, we can just delete the vector 2 construct and simply upgrade this point here. Let's see, this vector, this vec2 point, this vec2 thing here, to a vec3, or simply a vector. So it should be no problem. But as you can see here, we have some issues here. I'm paying attention to this first line. iTime was not declared in this scope, but we just call it time. We could also just go up here and call this iTime, so we steal the naming policy from the WebGL. I just like to go in and clean that up. So we do like this instead. Float. So lines 36. Pi was not declared in the scope. Pi was not declared in the scope. Fine. So that was what I explained in the start. And also we have a native construct called mpi. Mpi that does it for that. Otherwise, we needed to make a define here 3.1 blah 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 blah, and call that pi. We don't need to do that in that specific case. And this is a 8 arctangent. Actually, we have 2 values, so it's going to be an arctangent 2. And what is the problem? Frag color. So in the end, we're going to, as you can see here, the guy he highlighted that the output needs to go to the screen. But our output is not called frag color. That's again just a naming policy. I named mine output. I could have called it frag color, but that's just how it works. And as you remember, I said that the OSL does not return a vector 4 construct like X, Y, Z, and W. It's only a 3 component thing that looks like this. So we need to reduce this. We could go something like this to have consistency with our naming vec2 and vec3. So once I named that vec3, I need to make a new define here, vec3 vector. Let me compile that, F7, so it's still nagging. So it says, can I construct a vector point float? That's because it originally came with, that's the alpha we have here. So we're going to delete that. And it compiled. So just because it compiles doesn't necessarily mean that it will work. Uh, it's just now the code is fine. So I'm going to close this window down, and it was this node here. Let's try and grab some material here, something like this, and we need a UV. Let's see here, where's that? So that's there. As you can see here, we get our small symbol up and going here. So let me clean up these things here. I could hide this one and that one. Let's see here, get the grid up going. Put a plane up, something like this. Let me switch to the real shader here, and notice I run on the high quality here. So this is our material. We're going to assign it, and we're going to show realistic, turn off the shaded. See here. So and there we go. Just going to remove these things like this. Not really sure. It could be because it's the vec2 construct that we're not getting a signal in the viewport. I could potentially go in here instead of UV here. Could try. Could try and go something like this. No, it's not going to work, so it's something else. There, back to 1, something like this. And just one thing to pay attention to. So in WebGL, you can see here it's a little bit lighter, and that's actually a gamma issue. They have that implemented in the backend automatically, but in OSL we need to implement something like this. I'm just going to delete this again. So we go in here. So we go here. That means we go down here, and it's the output. So I'm going to take the power. That's basically a small gamma trick. We're going to take the power of the output, 2.2, something like this, and it should be working. So it will be interesting to see if this turns around. It does, but it's skewing. So something is telling me that we need to port this to let's see here, this one was okay. Let me go here, something like this. Let's go and check the code out. So it's activated a point. I have a vector 2 point here, cosine. Okay. Just 2 seconds. I need to deal with a cat that is desperate. Okay, cat is out. All is good. I'm not going to look into debugging this issue here, but I just wanted to show you some of the main lines of converting a shader toy, and I'll be doing this each Friday, taking some more and more advanced and explain a little bit about what's actually going on in here. But my main catch with this initial start is to give an appetizer to show you with a couple of tricks and some changes down through the code that we can actually go into to this site here and start to get inspired and maybe copy over some of the effects and start to learn a little bit about OSL shading, and shading in general. So so I guess I guess I'll save this one out. My general plan for these things are that we let me see what this is called. What was it called? It was called loading icon, something like this. My general idea is that whatever people ask about, whatever we come up with, solutions, part solutions, small code sessions, I'll save it out, save the scenes out, the stuff that isn't, I'm not using paid material with, and I'll upload it on a GitHub. So I'll probably do that next Friday. Get some links going to this GitHub. I'll basically just end up with a folder for each session with maybe a few or a lot of files. So I'm just going to save this file out here. We could return to solving the skewing issue here. I could sit down and look at it, but I think I'll spend the time on something else for now. So that was a brief introduction to that. Let me delete that. So let's see here. What do we have here? There's some red coming up here. Oh yeah, that was the volume displacement. Arnold volume displacement on generic mesh. That is why I had this clay thing going, so we could actually see. And let me just pump this up. Let me go in here, crank up the exposure a bit, something like this. And for sake of purpose of simplicity, I added a sky dome. I want to emphasize that the sky dome is not the fastest light from Arnold. I will probably say this 100 million times. HDR lights on geometry is probably the worst thing you can do in terms of speed. You would much rather want to use a quad light and use the projection, the color projection from that one. You'll be rendering at a much higher and faster speed. But I will cycle over this multiple times once I get hands of some issues from people. So I guess what is this? Well, it's a torus. It's a Taurus. It's a normal max Taurus. You can see here it has some resolution. But I have an Arnold modifier, properties modifier on top of it, and I opened the volume section. So and you can see here normally I'm going to stop this one. Normally you get a scenario like this. Actually, it's like this. Um, what you want to do is, of course, enable it, and you want to crank up the step size for debugging. You can this goes to 100. The padding is also going to 100. So 100 step size is maximum speed, but you will lose some details in here. All the small little wrinkles here. For example, I have a noise here. All these octaves here, and octaves basically just puts another iteration of details on the top of a tendency, another and another and another and another point. It's so small that you can't see it. Really, what the step size does is that it's skipping. You can see here it gets coarser and more coarse. And what you want to do, actually, you can see here something is happening over here once I do this, and you would never render finals with this high value, but it's really good for debugging and while you work, because it's extremely fast to render, while still giving some reasonable representation in the render view. And I have to say, I personally I prefer to use this Arnold IPR window over active shade, and definitely production mode. Production mode is yeah, you just keep hitting the render button and watch things. That's not the way I work. Yes, I do that for finals when I put things on the disk, but when I work, I always leave this window open, unless there's a very specific reason not to do it. If the application is slowing down, I think we have, let's see here, save UI threads. Yeah, so sometimes the application can become a little bit slow. Um, if you're constantly rendering, and you're using all the resources, things could start to lag. When I implemented this one, it's quite useful. You can also further reduce this by going to systems and auto detect threads. For me, I found that I have to mention that my system. Let's see here. I don't know if I can do that. No, I probably can't. But I have an i7 machine. It's a very modest machine. I have 6 cores, 12 buckets. So also keep that in mind when I do things. My machine isn't the best, but I have a decent 1080 card when we go on and work with the GPU. You can see here the GPU 1080. So actually now it's starting to update the scene. So we can't do anything. I'm not sure if the application will cope with this. It was a little mistake I made there. Shouldn't have switched to the GPU. One thing to note is that I've been punking the Arnold developers, fixing an issue with the padding. I'll return to the padding in a moment. Oh, we can take it now. But on the GPU, the padding is it's not currently working on the GPU. If the padding gets over 0.0, the item in the IPR will simply just disappear. So so that's not too optimal, but they have committed to look into it, and I hope I have a solution for that at the moment. Let me just see if I can do something less. I think maybe we're going to crash here. So this is also something you're going to become, you need to be familiar with once I do these sessions. We are likely to going to crash sometimes, and you will likely to see me post CER reports to Autodesk, and I might go to my other screen and make a note to the developers while we stream, so I don't forget it. So just process the box while it happens. So I think this one is dead. Let me go here. Let me terminate this one. Let me go in here. We simply just start up again. Now I do have this one, so I should be able to show you my machine stats. I have 6 cores. I have 16 gigabytes of data, and that's it. So now I made it possible to show you that. We'll wait for this one, and we'll pick up on the on the Taurus. So let's go here. This is the Taurus. We want to add the Arnold properties, volume, crank this one up. I'm going to add this padding now. The padding is basically how much room you're going to give the displace any form of displacement to reach out before it's getting clamped. So we set this one here, and we actually set up a shader that is actually going to displace. We'll still just see this, and we'll see some holes in the torus. But once we start to crank up the padding, it will actually start to displace this one uniformly. So, so why don't we go in here and pick up the standard volume. Going to slap that one on there. Something like this. We could pop in an Arnold light here, set it to Sky Dome, and 1 here, 0 there is basically normalized skylight. So just make sure you do that, and that is your base for moving forward. So let's see here. We're going to displace this. I wrote a shader here. It's going to be displacement. It's a small utility shader that is going to aid the Arnold displacement. Going to dehook this one. Actually, this can also go to the scatter color. Propagates the color of the incoming data, and see a bunch of code here. We're down to line 27, but actually what this is, it's this line. We take and move the displacement into true vector space. Otherwise we will get some drifting, and all the vectors will start to pull the object in like a 45 degree angle. It's a classic when people sit and work with this. They sit and think, why doesn't this work? And it's not working. But it's typically because the noise or the input they're working with is not conformed to a true 3D space. And what that means, let me just close this one and try and illustrate it. So I guess something like this. Let me just go here. Something like this. You have to pretend this is the X, Y, and Z in space, and the thing is that let me illustrate that like this, something like this. So normally we have a situation that looks pretty much like this. So standard noises, standard max noises down here, these OSL noises, and the Arnold noises, except if you set the Arnold noise. Let's try and find it here. No, wait, am I on the right one? Yes, I am. Texture, that's a slow noise. What is this one? Yes. So you can see this one, the mode is scalar, and we also have a vector down here. This is basically what this line does. It takes the scatter input and moves it into vector space. So while we can use the just 2 seconds, sorry. So while we can use the Arnold noise, and I will go through all the Arnold or many of the Arnold nodes here. If someone have problems. Let's see here. Yuri says, "Hi, hello, Yuri. Are you going to talk about the bloom and glare?" Yes, we can talk about the bloom and glare. Just finish this, and we will we'll go on to the bloom and glare. So normal noises are scalar. That means that this point, for every point on an object we want to displace, we want it to sit in the middle. But normal scalar noises actually looks like this. You have to look at it like this. It sits outside. This is 0.0.0. So what the shader I did and what a vector displacement actually does is moving. It's actually not moving the object, it's moving this coordinate system up into the middle here. So you have to pretend this is the unit sphere, and once you do that, you get displacements correctly in all directions without any skewing. The skewing typically looks like this. So just pay attention to these small things. I will iterate many of these things. Let's just get over with that and get back to the volume displacement here. So and as you can see here, I'm going to delete this one. let's pick up the 3D noise. It's there. Displacement, scatter color. We have some color going. So you can see here. Let me try and. You can try and see here. It's working fine. Something like this. So I'm going to go here. I'm going to decrease this one. I'm going to turn off stepping here. Get the amplitude back to 1. And start to get some uniform displacement going here. Let me crank up the density. We can use this scatter color. We can actually also use it for the scatter. So it became really dark. Sorry. Let me just pull this one out and crank it up so we can see what we're doing. Actually, you will end up in situations where things are too dark or too bright. I would strongly recommend against using this panel here. You can do it, that's fine, but you basically only have highlights, midtones and shadows, some saturation going, and we got all kinds of goodies going with tone mapper, white balancing, color correct. Look at this one, all these separating the bottoms, the middles and the highlights out. Separate saturation on those, and contrast, gamma, gain and offset, so it's much better. What I usually do when I pick up scenes from users is I just disable this guy, start to fabricate some image nodes here, because actually let me just go back to this one. These stacked things here, these here, are actually these nodes. They are connected behind the scene into whatever we do here. So now there's two. Now there's two nodes here. What was the other one? That was exposure. So actually, behind the scene, this is what is going up here. We just have a nice, convenient little stacky interface here. Makes it easier. We can go in here. Let's see here. Let's go to the bottom here. You can actually see that this is the root imager and this is the connection point. So if I pull this one out, you actually see this I just built up here. So I'm deleting this one. This is actually what's happening. It's connecting these nodes up automatically. So that was just a small thing about that. I'm going to delete those. So what else can we say about this displacement here? Oh yeah, I forgot the padding. So on the CPU, this is working great. It's always been working, but on the GPU, unfortunately not. So you can see here, I can clamp this, and it could go further. And the more we start to push this one out, the more padding we need, because to get the full effect of the displaced noise here. So so while you can use it, you can see we get some nasty stepping here. These are actually the voxels. So we would just want to crank this one up. You can set it to 100, but that's going to be rather costly. So this is Arnold has several places where sweet spot, the term sweet spot is a critical thing. So depending on the effect you want, just set it to the sweet spot so you don't uh, use excessive computation to get something going. So let's check the bloom. Yuri talked about bloom and glare. So I have to say that the glare is it's not a separate effect. Glare for now. Glare are small glints. They are very contrasty, very high intensity. You can produce a glare with the bloom with a very small radius and some contrast. But glare as a glare is, we don't have that at the moment. So maybe I should close this down here, reset, something like this. We built a small test case for a bloom and glare. Um, I always usually I go something like this. Okay, Arnold renderer, something like this. Um, small thing. If you start to go, actually, this is a thing Zero also mentioned. People that are coming from things like Corona and stuff like this, they get a little bit lazy, and they just whatever. There's not enough light here. Let's just crank it up, and you can do that. And you can also use light mixer. Uh, we can get over that, um, boosting those. But in general, I would recommend you. I think the app just crashed. No, it didn't. So that was good. In general, I would start to just fry up the light here. Um, and then if you need more exposure, go in here and increase it. So if we, I made this one to illustrate the bloom, and I basically just made a floor here and a lamp to get some kind of shiny deal going, because we need to of course we need some specular component, high intensity specular component going for the bloom to kick in. I'm going to use the physical material. In general, you will see me use the physical material because I just know SAP will like that. And it's kind of like some new standard we want to push for 3D Studio Max, while it's a wrapper on top of the well-known standard surface, Arnold standard surface. So many of these, if not all, no, not all, but many of these Arnold standard material entries will propagate to the physical material. There are some things in the SSS and sheen and stuff that is missing, thin film, not thin film, but in general, and the Arnold material here, while it's good, it has some really nice extra features here, transmit AOVs. We have some things down in the subsurface here. We can set different versions with the physical material in the render session in the render panel, but uh, use use the physical material in 3D Studio Max whenever you can, and if you run out of options, pick up the Arnold standard material. The physical material also works really nice in the viewport, and we have the PBR material. This one, I think it was Yuan that made the initial code for this. This is 3D Studio Max beta tester, and SAP picked it up, and this is for PBR. And this material is basically a wrapper around the physical material. So use that whenever you can. So fine, we have some kind of reflection going here. I'm going to pick this one out. I'm going to advanced reflection, roughness, something like this. And for Yui about the bloom and glare, I actually think I saw Eloy. Eloy actually have some nice tutorials about this. I'm not sure, but if he has, he can paste it in the chat. For now, I'll just show you how to add this, and it's in the lens effects. You can see here, it's up here, it's bloom, and you can add in strength here. Let me see, what is this not working? Let me see here. Why is this not? This is not kicking in. Let's see here what I did wrong. What is my problem? What is my problem here? We actually should see something. The thing I'm looking for is updates when I move these, because the images are overlaying, and I'm not really sure why this isn't picking up here. Let's see here. So let's just take it from the viewport side of things. When you debug, you have a bloom down here. Let me go to a grazing angle. Oh, you started to see here the screen is flickering, something like this. We have a strength here. Yeah, so you can see you start to get an effect here. Maybe I need to go here, something like this. Yeah, so as you can see here, you actually get the bloom effect going down here. So while this is not Arnold, we actually have a recent introduction. You can actually see it better when I move around like this. You get the bloom effect here. I just wanted to show you that you can. Let me see here. Quality. Yeah. Actually, what you can see here now, you can see it's square, and it starts to getting more round. That is because the way the bloom is done is that the kernel that generates it is actually done in a square. So if we do like this, we can look at this one, and let me just go in here. Let me go in here, something like this. Convert this to a polygon, like this. So and you see this square up here. So what is happening is that it's sampling this area in a square, and it's starting to pick up these squares over here. So that means it goes into something called a for loop, That's when some kind of effect is looping um, to get more samples, and that is the quality you see down here. So that was just a little sidetracking, a technical explanation about this. And the thing is that the square method is the cheapest way to produce a bloom. The Arnold bloom that I for some reason couldn't get going. So let's try and see here what I couldn't get that going. We can try a different scenario. Let me delete this one. Let me create an environment here. Something like this. Standard volume is not what we want. We want the atmospheric volume. Where's my slot? It's there. Something like this. Let's look at this one. Did we turn this one? Yes, we did. We're just turning it back. Something like this. And we have a density. Something like this. So what we actually have now is a lot of fog. This is a universal effect. It's actually okay. What I much rather prefer is to use boxes and objects that controls local atmosphere, where we use the generic standard volume because it's more flexible and you can turn things on and off really fast. Let's try and see here. I'm not sure if it's my build. Let me go in here, color correct this one so we get a contrasty guy going here. I might need to reset lens effect. I see I'm not getting any you can see here whenever I'm not getting anything. So any of you guys in chat know if this is broken in the public build? I'm not I'm not receiving any input here. This is quite unfortunate actually. We could try and load a different scenario. We could go and do a little bit of debugging here. Something like environment. Environment, we could pick the HDRI environment. Something like this. So we have some kind of map here. We should be able to render this one. There. Lens effect. Lens effect. I'm getting 0 input on this one. I'm getting no, there it was. Oh, okay. I actually know why. It's because the image needs to be finished. So what we need to do is go in here, make this one really fast. Something like this. Okay. Yeah, 0. I thought something like that as well, but just turned out it was me that was retard. It happens. I was impatient. I wasn't waiting for the image to finish down here, so I was just going like, what the fuck is happening? But this is basically it. So you have your windows, you have your strong lights. You need these kind of intensities, HDRI intensities, or like I showed, a light or a reflection of something, or a normal light, a spotlight, a hard light. That will also work now in my build. But as you can see here, um, when I enable it, we get the aberration going here. Looks really good, and the quality. There's no, as you saw in the viewport version here, the bloom down here. The quality, we don't have that in Arnold because it's always. Sorry, just 2 seconds. I'm not used to speak this much. So so on the Arnold Bloom, you won't you won't find that quality spinner. Actually, you're seeing the bathroom. You had some spotlights, and I suspect that you asked the question about the blooms because you had like you have some lights up in the ceiling, and in front of that glass, the mirror, that you want to give some slight bloom, like if you pretend this is one of your small spotlights, we can work in with that one. So or we can look at this one. That's perfectly fine as well. But as you can see here, you obviously need to turn it up, and you can just let it rip and go totally overboard, while it's still preserving all your normal lit geometry. It will just crank up the high intensity zones, like your spotlights. So just what you want to do is nurse this strength here. Of course, the larger the radius, the more bleeding you get. You can see the door is getting very bluish, green bluish. Has a really nice fall off color here. So you want to make sure about you get the right radius. Um, and I wanted to say that while we don't have a glare, um, we actually do have something like a fake glare. We can move this radius really far down, and as you can see here, uh, you start to get some intensity, while it's not like bleeding crazy with a huge radius. So what you wanted to do, if you want to have a glare and some bloom, you would actually add two of these lens effects here. We actually need to tell the Arnold developers that we should be able to rename these. I want to be able to rename this to bloom and this one to glare. All right. But I'm right clicking here now. Oh, I can. Awesome. Bloom. I can also double click it. It becomes better and better. Um, okay, fixed. That was an easy thing to fix for the developers. They just had to wait for me to find out that the application actually could do renaming. So for the bloom, I would actually I can't move this one around, so I want to I actually want to do like this, because that's just That's just who I am. Um, so for the glare, um, small radius is your friend, and you want to play around with the strength. So your small spotlight up here gets the sufficient effect that you're looking for, and you want to enable the bloom and crank the radius up. I'm not sure if we can do double here. Yeah, so something like this. This is totally exaggerated, but that's just to show that we now have some form of glare and a bloom. Of course, this is way too much. So I would do more like this, right? So we got the big bleed out here, and we have the small intensities. So I think that was I think that pretty much covers glare and bloom. Yuri, I want to actually address something from your scene yesterday or from 2 days ago. It's common mistake. Cyril mentioned it that we typically when people come from something like Corona, renders of that nature, uh, tend to use the same thinking, the same methods, the same workflows for Arnold. And while that works in some cases, it's not always guaranteed that you will get an ace result in Arnold using the exact same technique as you would do in Corona. Uh, but we can still manage to get an ace result with Arnold with just a couple of tweaks and sometimes 3, 4, 5 tweaks. And we need to pay attention to those situations where it gets a little bit too complicated for the users, so they tend to just it's just too much. So we need to make that a focus for the developers, so they make it more simple. But I want to pick up. I want to pick up on your scene, Yuri. I'm not going to load it. I'm going to just create a small dummy scenario here. So let's see here. Um, so maybe I'm going to load this room here. I actually made this one in a studio, student version, way back. Let's see here. The scene is loading. All right. So the thing I wanted to address, that's about speed, render speed. Uh, we always want things to be done yesterday, preferably the day before yesterday. We don't want to sit and wait for huge times, and it gets annoying, and you get stressed, and you get burnouts, and some people even take their own lives. So we don't want that. We want fast scenarios. And what I saw in your scene, Zero, or not Zero, Yui, was that you had some kind of, you had a spotlight. So let me just go in here, let me create, let's see here, that's going to be a tube, something like this, and I'm going to throw in a cylinder, something like this. Alright, this is our new awesome lamp. It's very, very big. This is a halogen lamp. Why don't we just scale this guy down? Let me see here, something like this. How can I show this the best way? Let me see here. So we just, for the sake of this explanation about things to take great care about, is that, oh, let me go over here, clay. I have more space, something like this. There we go. Let me put this one far into the corner here. So for the sake of this, you might end up downloading something like Arc interiors or Arc models, and you need to populate 50 of these lamps. And the normal thing you usually do is that the lamp comes in shaded with chrome, and there's some self-illuminating material, and probably or might be there might be an IES file associated with it. So that might work in Corona. You can add the self-illumination to get some bright stuff going up here, because let's see here. Let's see here. What is it that we have here? Probably need to. Is this on the GPU? This is on the GPU. So I'm going to switch back to the CPU. Actually, what I'm going to do is I'm going to go like this. I want to. I just want to hide the other stuff for the moment. Something like this. Alright. Something like this. What happens if we render this? Let me just check here again. So I don't need this. This is far too much on the CPU. I don't need box filtering. That's for actually when you render quick renders OpticX, remember to set it to box over here. Otherwise you will get bad result on the denoiser. Let me see here. Does it save? No, it doesn't. Let's go here. Where did that window go? Oh, it's down there. It was almost. Oh, I closed it down. There we go. So just need to make sure that my this one. Okay, so it's still affecting the scene. That is fine for now. I actually don't like that, so we're going to delete it. I'm going to put up a new one here, something like this, and usually you get something like this, photometric. Let me see here, where were those IES files? I think I deleted them, so I'm just going on my other screen here. Free IES files. I'm going to download. I'm going to no, actually, I'm going to go to my Discord. So just have some patience with me. I just need to find some IIS files. I have a bad habit of deleting everything, always, constantly. I hate having things, and I'm exactly the opposite of people that likes to save and store things for eternity. I delete everything as soon as I can do it. Let me see here. This Yuri, I'm going to use your files. I'm on Discord right now. Let me see here. I can't find your post. Was it in Yuri? Was it in your? Yuri? Was it in your texture file or the other one? I don't remember. Let me see here. Maybe I need to. Maybe I need to go here. I'm basically right now. I'm just searching for some IIS there. I found it. So I'm going to download it. And this is actually this is a critical thing that a lot of people are getting wrong, and it contributes to a ton of noise. I guess, did Zero say something important? It works in Corona, but it creates a lot of noise. So even in Corona, it isn't the best solution. Okay, so basically they end up with the same issues. And the problem is that the self-illuminating material that you typically put on something like this. Let me just do that. Something like this. Emission. This is going to be white. Arnold, ding ding ling. So we start to get something here. And did I get the HDRI files? Yes, I did. So I can now go in here. This is the pack. Goody goody. Let me go to the lamp here. Pick up one of these. This is going to be overhead parallel beams. Do we think this one is going to work? It did. All right. So I'm going to normalize this one first. Something like this. All right. So we now have our IES light going, and we have we don't have the other polluted light. That's correct. So right now, this is typically one of the scenarios that you do. You have some kind of effect here. Obviously you want some reflection from the light up here, and let me just pull this one up here. Terminate the emission. So as you can see here, if you just put in the light and crank up the emission, or if you just put in the light, you won't get some kind of effect up here. So typically what you do is you use an emission thing here, And if you start to become do nasty things, you start to do something like, let's see here, what's that called? That's the emission color. So let's go here, and just for the sake of it, we're going to pick something like this one. I don't, okay, it's working. So let me just write a small shader here. This is our spot multiplier. So I could have pulled out something, but I didn't. I'm just going through these things here. This is a typical day-by-day solution. If you sit and code, so we might as well just get a lot of small examples out. So what I did here is I created a shader called spot multiplier. We have an input called spot. It's this entry up here. We wired up to the emission here. And let me go back to this one. But nothing happens because you can see nothing happens. The reason why it's gray is because of the bouncing light from the IAS light here. So what we want to do is we want to connect the output to this float value up here. We do that by, sorry, 2 seconds. We go in here, out equals spot. Oh, not colon, but semicolon. All right. So nothing happens, but that's because the value is not a lot. In fact, it was 0. So here we can start to crank this one up, and you start to see some excessive noise from this emission here. Let me just go back here, see if I can snap this one in here like this. Let me not disable that one. Let me shrink this stuff a little bit down, something like this. So let me see here. So we need to debug this. We need to make sure that this material only sends out direct rays. That means rays that are received from the camera. We don't want this small bright thing to start emit light and create a ton of noise. Let me go down here. The way you debug these things are that you disable your lights. You can see here all this noise here. This is actually coming from okay, the reason why we didn't see that is because we are cheating. We're using a denoiser, so I'm disabling this one. I think this is a little bit too dark, so I'm going to crank it up. And this is probably one of the main causes for people that make spotlights. They have issues. Let's see here what X0 says. The self illumination material. Yeah, okay. Okay, it's called that. Okay, in Corona. So we don't want that. We don't want this material to send out all this light here to this plane here and all the other geometry. We wanted to send out the reflection, but we don't want to send out the GI. So let me show here. No way I'm going to use tput. Something like this. Did I place this correctly? I did. Let me crank this up even further. So you can see here, if you're set in some kind of situation where you need to manipulate exposure a lot, because your scene is perhaps dark or for the reasons, artistic reasons, and you don't solve the issue with a doubled lighting, where you have your correct IES light. It was this one. You can see while we have that light, we also have all these nasty fireflies out here, and it's going to take forever to clean those up. So what we want to do is basically create a scenario where we still get the full white up here, because that's the only thing we want. We want a full white surface up here, and we want the ES light to pick up from there. So something like this, and a completely white surface up there. So there's a couple of ways we can do that. Let me crank this up so it gets really nasty. Let's see there. Okay, so the way we do that is with one of the utility materials. We can actually also use a switcher, but that would be on this or use a shader. But that would be in slightly more complicated scenarios where we. I'll get back to that for sure in the future. I just need some questions, and eventually we'll stumble into it. So we want to fire up this this ray switcher here. This is basically an expanded control board for controlling rays on any given material. So that's kind of convenient, because the material we want to control, there's only one. It's this one. So let me just pick up. I think I want to shrink this one down and shrink this one even further down, so I get a little bit of room. And let's go in here and address the situation. So once you do this, make sure that you make it easy for yourself. So you just debug, because it can be difficult to check things if you need to, if the scenario is like you're right in it, as Anselm used to say, or still says, in the grid. It can be difficult to check out what is what here. So just turn it off. Let me go back here. Something like this. We can now see our lamp. We can see everything. Just turn it off. That's actually what I did with the US scene. Started to debug, and I saw a lot of excessive noise in his room. So instead of using this is a cool thing about the Arnold frame buffer. We can select objects here. So if I had this one, I could just select here, and you can see it selects the box and T-bot. And instead of going down here and fiddling trying to select this one, I could just go up here and click this one and assign this material, and everything turns black. The reason why everything turns black is because there's now all lights are disabled and we have no self-illumination. So what we want to do is we want to hook up this self-illumination material to the camera rays. As you can see here, we have exactly what we want. And this renders orders of magnitudes faster. And that is basically it. We can turn on our light down here, and as you can see, we have no excessive noise going, and we have our nice little illumination thing going up here. So that's it. Use this ray switcher. You don't need to use this one. I'm going to save this one out. We call this the spotlight. And I'm going to create a GitHub, a new account for these Friday cafe sessions, and I'm going to upload these things here. So that's it, and that's kind of like the thing with Arnold and I guess Corona and other render engines. You need to pay attention to what kind of rays your materials are sending out and your lights. You can also use this ray switch approach on lights. They have that stuff integrated down here. It's the same. You can see the logic here. So that's it. So I guess that's it. I don't know if Yuri is here. He's probably gone. But try and implement that, Yuri. If you come back and watch this stream, you asked about the bloom and the glare. We went over that, and I picked up on what I think was the most serious issue with your interior scene. I guess let me see here how long have we been going for now. We've been going for 108 minutes. So right now it's 19:33 here, and I actually need to go and do some shopping. Otherwise, we won't get something to eat again today. I didn't manage to go and get shopping last night. I saw the clock when it was past shop close. So we only ate what we had. We don't want to do that because it's Friday and we probably want to start the barbecue. So go down and get some sausages, some bread, and what have you. But I think this will more or less be it for this session. I'll pick up next Friday. Make sure that we get some more attention. I basically did zero effort to get some attention to this live stream. But I imagine also in the future we could get people in talking about a little bit of stuff, and of course I want questions from people. Actually, one thing I can do, that's the last thing I'll do before I terminate this one. It was from Mike Kuhn. He's a 3D Studio Max beta tester. He was commenting on our favorite guy, Lee Griggs. He was commenting on, actually we can see it down here, it was this post here. So Lee posted a tutorial he made on YouTube. He started doing that. I think it's awesome. Very nice. Also to hear his voice and all that. But as you can see here, Mike he likes it. And basically, what that is the effect is that it's like a stepping. It's like architects. They cut these small thin boards and glue them together and make models, and you kind of like this is the effect that you get with this. And he did this in Maya. I'm going to close this one down. So this is the effect, and he goes over how to create this effect. He loads an Arnold noise, make it. I suppose this is a float. This is from Maya. He's multiplying something. He's multiplying color to float. Okay, so he's turning 3 channels into one, and return an integer from that float and displace it. So he gets a useful signal and explains a little bit, and eventually end up with some kind of expression that looks like this. And this is the meaning of the tutorial, that you get some kind of fancy stepping going. So I thought I would. I actually told Mike here. Let me go back to his post. Let's see here. There, I actually committed. I'll pick up on it on Friday. And that is now, so I'll do that now. I'll reset this one. Reset. No, something like this. We'll create a max plane. And what I will do is I'll use the 3D Studio Max generic viewport displacement modifier here. He's using Arnold displacement, which we of course also can use, but I'm just going to preview this effect directly in the viewport. So play, and we want to crank the resolution up. Let me just type in here 100 and 100 something like this. And let's take one of Sap's awesome noises. Maybe this one. And we're going to put it to to the modifier here, and we're going to displace this guy. Let me do something like this, something like that. So basically this is what Lee is doing, but we are totally missing the stepping part. And that's actually quite easy to do in OSL directly. We could build the shader that he did with the node that he did, but I'm a sucker for OSL, so every time I get a chance to do some OSL, I'm doing OSL. So what we actually need to do here is go in and just intercept the output and turn it into an integer. That will basically just do it. So let's go up and look what is Sap made this shader here. So his output is called out. So that means if we go down here in the bottom, we address out. So now we want to change something in the output called out. We're always sure that we catch the last signal. That means just before we send it to the bitmap. So out what? Well, we want to output the output, but we want to do it in an integer fashion. And lo and behold, we got something going. So let me just go here, something like this, and for the sake of this, I'm going to turbo smooth this one. There. So that's it. Actually want to go. Whoops, something like this. Yeah, something like that. And we can face this, and it will step just like his. So that's it. That's it for this effect. You actually only need to write one little line in OSL, and you can turn the awesome bass OSL noise into some kind of stepping displacement effect. This will work, of course, as Arnold displacement, and it will work in the viewport. And it will take the height values of the original noise and just step them. So I guess that's it for the first day. I think I can't say everyone because that sounds like I had a million people on the first stream here. I did not have anything close to a million. We had a couple, and that was very nice. I'll just go and see. It's because this window needs to go over here. Let's see here. Something like this. And I feel pretty confident about doing this. We actually only touched 2-3 very small light subjects. And we went on for, let me refresh this page, about 118 minutes. It was not an issue. So I'll be doing this again on next Friday, and I will ramp it up a little bit. I will try to get the message out there and see if we can get a little bit more people on. And I basically don't care how many there are. I'll just continue to do these, and I'll figure out stuff to cover until this starts to manifest and people starts to come in on a regular basis. We can pick up on all kinds of things: interior lighting, architectural things, shading, optimizing shots. We can, if users have scenes that they have problems with, then upload them, and I can download them, and we can try and debug them together, and try and optimize or find a solution for you. So yeah, I think that's a wrap for today, and I have 15 minutes to go down and buy some stuff for the barbecue. So see you on next Friday.